You look at your hands right now. You see the skin, the lines on your palm, the solid shape of your fingers. You feel the weight of your body pressing down into your chair, and you feel the chair pressing back up against you. You knock on a wooden table, and you hear that solid, reassuring thud. Everything in your biological experience tells you that the world is made of stuff, solid, heavy, tangible, permanent matter. But what if I told you that everything you see, everything you touch, and even the very cells that make up your eyes and brain are practically made of nothing? What if I told you that if you could somehow remove all the empty space from the atoms of every human being currently living on Earth, the entire population of the world, all 8 billion of us would fit inside the size of a single sugar cube? Just think about that for a second. 8 billion people compressed into a tiny white cube on the palm of your hand. But here's the kicker. Even though it's the size of a sugar cube, it would weigh 5 billion tons. It would have the same weight as the entire human race, just without the room between the pieces. That should break your brain. It should make you question the very ground you're standing on. Why don't you fall through the floor? Why doesn't your hand pass right through your other hand like a ghost through a wall? Most people think they know the answer. They say because things are solid. But solid is just a word we use to hide our ignorance of what is actually happening at the atomic level. When you dig into what Richard Feynman uncovered about the nature of reality, you discover that solidity is an illusion. You are 99.9999999% empty space. And the story of why you feel solid is far more explosive than anything you were ever taught in a high school classroom. To understand this, we have to start where the great avalanche of discovery began. We have to look at how we learn to trust the invisible forces that govern the world. Let's look at the moon. The moon is staying up there, orbiting the Earth in a perfect, silent circle, night after night. But is it falling? People used to think the moon stayed up there because it was held by some celestial sphere. But Isaac Newton looked at the moon and realized something radical while sitting in his garden. If you drop a rock on Earth, it falls 16 feet in the first second. Galileo measured it, and it was a solid fact. But Newton wondered if that same pull reached all the way to the moon. The moon is 240,000 miles away. We are 4,000 miles from the center of the Earth. That means the moon is 60 times farther away than we are. Newton proposed that gravity follows an inverse square law, that it gets weaker not just with distance, but with the square of that distance. If you go 60 times farther away, gravity should be 60 squared, which is 3,000, 600 times weaker. If gravity is 3,000, 600 times weaker at the moon, then the moon should fall toward the Earth by 16 feet divided by 3,600 inches 1 second. Do the math in your head. 16 feet divided by 3,600 is about 1/20th of an inch. When Newton did the calculations for the moon's actual path, he found that it curved away from a straight line by exactly that amount every second. The moon is falling, but it's moving sideways so fast, thousands of miles per hour, that as it falls, the Earth curves away beneath it. It keeps missing the Earth. This was the first time in human history we realized that the same invisible laws governing an apple in an orchard also govern the giant rocks in the heavens. It gave us the confidence to look at the invisible and trust what the math was telling us. Because when a law is right, it can be used as a stepping stone to find the next one. And that confidence eventually led us to look inside the atom, where we found a reality so hauntingly empty it shouldn't be able to support a person's weight. For a long time, we thought atoms were like little billiard balls, solid, indestructible chunks of matter. But then we started shooting particles at them, trying to see what was inside. If an atom were a solid ball, the particles should bounce back like rubber balls hitting a wall, but they didn't. Most of them passed straight through as if there was absolutely nothing there at all. Only 1 in thousands bounced back. This led to a terrifying realization. The atom is almost entirely empty space. To visualize this, imagine an atom expanded to the size of a massive professional football stadium. The nucleus, the center where nearly all the mass is concentrated, would be the size of a small marble sitting right on the 50-yard line. And the electrons, they would be like tiny microscopic gnats buzzing around the very highest seats in the stands, miles away from that marble. Everything in between that marble on the field and those gnats in the stands is absolutely 100% empty space. There is nothing in there. No air, no gas, just a vacuum. Since you are made of trillions and trillions of atoms, that means you are made of that same terrifying emptiness. If you are 99.9% empty space, then the chair you are sitting on is also 99.9% empty space. The floor is empty. The walls are empty. The entire earth is mostly nothing. So why are you sitting there? Why aren't you falling through the empty space of the chair, through the empty space of the floor, screaming all the way toward the center of the earth? This is where Feynman takes us deeper into the machinery of the universe. You think you are touching things. When you press your hand against a wall, you feel resistance. You think the atoms of your hand are hitting the atoms of the wall, like two rocks clashing together, but they aren't. They never even get close, not even by a long shot. Every atom is surrounded by a cloud of electrons. The electrons in your hand carry a negative electrical charge. The electrons in the wall also carry a negative electrical charge. And as you know, like charges repel each other. As your hand gets close to the wall, within a microscopic fraction of a millimeter, the electrical repulsion between those electron clouds becomes so incredibly massive, so violent, that it stops your hand from moving any further. You have never truly touched anything in your entire life. You haven't even touched your own clothes. What you perceive as touch or solidity is actually just the interaction of invisible electric fields pushing against each other with incredible force. When you sit in a chair, you are actually hovering a microscopic distance above it, supported by the invisible springs of electrostatic repulsion. You are levitating, held up by the sheer power of electricity. Solidity is not about stuff being in the way. Solidity is a war of forces. You are a ghost made of empty space, held together and kept apart by invisible lightning. If you could somehow turn off the electrical charges in your body for a billionth of a second, you would instantly dissolve into a cloud of dust and fall through the floor. Now, we have to address a big misconception that even some scientists get wrong. We talk about atoms like they are tiny solar systems with little balls orbiting a center. But Feynman hated that image. He knew it was a simplified lie. If you really want to understand why you feel solid despite being empty, you have to stop thinking about particles as little rocks and start thinking about fields. Imagine the entire universe is filled with invisible sheets or fluids like the surface of a quiet pond that stretches in every direction. There's a sheet for electricity, a sheet for magnetism, a sheet for every fundamental force. We call these fields. When an electron jiggles, it creates a ripple in that field, like a stone thrown into a pond. Think about two magnets. You felt that invisible cushion when you try to push two north poles together. You can feel the resistance, you can push against it. It feels like a physical thing, but there's nothing there you can see. What is between those magnets? Feynman would tell you it's the magnetic field, distorted and under tension, like a thick rubber band being stretched to its limit. Everything you think of as a thing, an apple, a car, a human being, is actually just a localized jiggling of these fields. When you touch that table, the fields in your hand are interacting with the fields in the table. It's like two high-powered fans blowing air directly at each other. They don't have to touch to push each other away. The empty space inside your atoms isn't really empty. It is actually filled with these intense, vibrating, high-energy fields. How do these fields talk to each other across the void? How does the wall know your hand is approaching before they touch? Information has to travel through the fields. And this brings us back to what Ole Rømer discovered with the moons of Jupiter hundreds of years ago. He found that light, which is just a ripple in the electromagnetic field, takes time to travel. It isn't instantaneous. This means that nothing in the universe happens at the same time everywhere. If I move a magnet here, the magnet on the other side of the room doesn't feel it until the ripple in the field reaches it. This delay is what we call the speed of light. It is the maximum speed at which any force or any message can act. It is the speed of now. Wait, think about that. If information takes time to travel, then the solidity you feel is actually a delayed reaction. Your brain receives the signal of touch through your nerves, which are themselves powered by moving electrical signals. Everything about your existence is a conversation between fields happening at the speed of light across vast distances of empty space. Feynman uncovered that light, electricity, and magnetism are all just different ways of looking at the same fundamental field. When you look at a flame, you are seeing the jiggling of charges, releasing energy into the field. When you feel a magnet, you are feeling the tension in that same field. But here is the mind-breaking part. If you are 99% empty space, and that space is filled with fields, then what are you, really? You aren't the marble in the stadium. You aren't the gnats in the stands. You are the tension between them. You are the energy stored in the emptiness. Most people think mass is something you have, like a collection of heavy rocks in a backpack. But Feynman showed us that mass is something that arises from energy. Einstein gave us the famous formula E equals mc squared, but Feynman showed us the how in the context of the atom. The reason that sugar cube-sized ball of humans would weigh 5 billion tons is because of the incredible amount of energy required to squeeze those fields together. You aren't made of matter. Matter is a secondary effect. You are made of energy that is pretending to be matter. You are a pattern of vibration in the vacuum. You are a localized knot of energy that has decided to stay in one place for a while. We've established that you are mostly empty space, and that this space is filled with vibrating fields. But now we have to ask a question that most people never think to ask. Where does your weight come from? If you go to a gym and stand on a scale, and it says you weigh 150 pounds, where is that weight located? You might say it's in the atoms. But if you add up the mass of the actual particles, the protons and neutrons in your body, they only account for about 1% of your total weight. So where is the other 99% of your weight? It's in the empty space. It is the kinetic energy of the gluons and the potential energy of the fields holding your atoms together. Your weight is literally the energy of the nothing inside you. Energy and mass are the same thing. This is what it means when Feynman says that the world is a great chessboard and we are only seeing the moves, not the pieces themselves. This leads us to the most famous limit in the universe, the speed of light. Why can't you, a creature of energy and empty space, go faster than 299,792,458 meters per second? If you are mostly nothing, why can't you just slide through the universe at any speed you want? As you try to move your empty space faster and faster, you have to push those fields through the vacuum of space-time. But as we learned from Einstein and Feynman, as you approach the speed of light, your inertia, your resistance to being pushed, starts to skyrocket. The faster you go, the more the energy of your motion adds to your mass. It's a feedback loop you can't win. By the time you reach 99.99% of the speed of light, you have so much mass energy that you become almost impossible to move any faster. Even a tiny push would require more energy than a supernova. To reach the speed of light, you would need more energy than exists in the entire universe. You are a victim of your own energy. Because you are held together by fields that propagate at the speed of light, you cannot move faster than the very thing that defines your existence. To go faster than light would be to unravel the fields that make you solid. Your atoms would literally lose the ability to talk to each other. You would cease to be a thing before you ever reached the limit. You would dissolve into pure information and energy. Why is the limit exactly that number? Why not 300 million or a billion? Feynman uncovered that the speed of light isn't about light, it's about causality. It's the maximum speed at which a cause can lead to an effect. It is the frame rate of the universe. Imagine you are looking at a star that is 10 light years away. You aren't seeing it as it is now. You are seeing it as it was 10 years ago. The now for that star hasn't reached you yet. If you could travel faster than light, you would be arriving before the information of your departure could ever reach your destination. You would be breaking the sequence of time itself. You would be able to kill your grandfather before your father was born, because you are made of fields, and fields are limited by the geometry of space-time. You are a prisoner of the present moment. The emptiness inside you is governed by a cosmic clock that won't let you cheat the system. You might say, Feynman, this is all very poetic, but how do we know it's not just a fancy math trick dreamed up by people in white coats? Well, we know because your world would literally stop working without these rules. Look at your GPS on your phone. The satellites providing your location are moving at thousands of miles per hour, and they are in a different gravitational field far above the Earth. Because time is flexible, because the empty space and fields are affected by motion and gravity, the clocks on those satellites tick at a slightly different rate than the ones on Earth. It's only a few microseconds, but it's real. If we didn't use Feynman's and Einstein's equations to adjust for this stretched time, your GPS would be off by 10 kilometers in a single day. Within a week, the system would be so far off that you'd be looking for a gas station in the middle of the ocean. The fact that you can find a tiny restaurant in an unfamiliar city is living, breathing proof that you are a creature of flexible space-time. Then there are the muons, tiny, ghost-like particles that decay in the blink of an eye. They are created high in our atmosphere by cosmic rays, and they should die long before they ever hit the ground. Their lifespan is too short to travel that distance. It is a physical impossibility. But they are moving so fast, 99% the speed of light, that their internal clocks slow down relative to us. From our perspective, they live longer. From their perspective, the 10,000 meters of empty space between the sky and the ground contracts. It shrinks into just a few hundred meters. They reach the ground because the universe literally shrinks the distance to accommodate their speed. We see them, we measure them, and they tell us that space and time are not what they seem. So, what have we uncovered? You are 99% empty space. You are a collection of invisible fields jiggling in the vacuum. You have never touched anything in your life, and you are held together by raw energy that gives you the illusion of weight and mass. This is the avalanche of discovery that Newton started. It started with an apple and a moon, and it ended with the realization that matter is just a word for a very complex, very beautiful knot of energy. We are not separate from the universe, looking in. We are the universe jiggling in a very specific, very rare way. Physics doesn't take away the wonder of being human. It doesn't make the world cold or mechanical. It adds to it. It tells you that you are a walking miracle of electromagnetic tension. You are a ghost made of starlight and vacuum, capable of looking back at the infinite universe and asking why. I'll leave you something to imagine. If you are 99% empty space, and the solidity you feel is just a force field, what else in your life is just an illusion created by your limited senses? What else are we missing because we trust our eyes too much and our logic too little? The great chessboard is still there. We've only learned how the pawns move. Imagine what the rest of the pieces can do. If this collapsed your understanding of reality, good. That means you're starting to see the world like Feynman did. Would you like to explore why time might be the greatest illusion of all? Or should we look at what happens when you try to squeeze that empty space into a black hole?